Hello there, ladies and gentlemen. In this section, I'll be talking about the Haber process. Haber process is a chemical reaction in which massive scale, industrial scale of ammonia is being produced. Well, what is ammonia? Ammonia is used for fertilizer, chemical, and in warfare. Not chemical warfare, just warfare. Well, and it was first produced in a mass scale by Haber and Bosch, German scientist, German chemist to be exact. Well, after the Le Chatelier's principle has been proposed to the scientific world of journalists and so on, Haber and Bosch decided to make ammonia based on massive scale. Well, the story goes like this. Before the World War I and during the World War I, what happened is that France, Germany, and Russia, and Great Britain put a blockade in Germany, and Germany needed ammonia without outside world, so they had to produce ammonia. And what they do, because they have a very amazing scientist, as they had and even they still do today, they made ammonia just by themselves. Before, they used to get it from Argentina and South America, but and the way they did it is very beautiful. Le Chatelier, Henry Le Chatelier tried to do this and he failed, and his assistant died, and he said that his greatest failure in life or scientific world that he said was not able to make it this process. Well, this is what the Haber did. The Haber process, as I said, was the producing mass scale of ammonia, and by the way, the Germans used that to make weapons so they could fight a war. Okay, and Haber is also known as the guy that made the chlorine gas. Yes, and he's a very few scientists that innovated, made scientific discovery, but not enough for greater good, but for the bad for human race. Anyway, that's enough for Haber. So what Haber did was, the first thing he did was this. First of all, he took the methane and steamed water and turned it into carbon monoxide with hydrogen. Okay, so after taking that hydrogen and then he mixed it with air, and this is in a closed system, okay, and remember that the equilibrium needs to be in a closed system. So when he mixed it with air, you know that air has around more than 70% nitrogen. So based on that, based on formula and based on that chemical reaction, he produced water and nitrogen. All right, and then he took that nitrogen, and then he mixed it with hydrogen, and he made ammonia with heat. All right, and the way he did was he used mainly two things. Okay, so based on Le Chatelier's principle, like we said, the more pressure you put on something, and if that pressure if it has more moles, more concentration in a product set, and if you put more pressure, the reactants will be more. If it's reactive, the product will be favored. So what I mean by that is like going to be complicated, but this is pretty simple. So we have hydrogen and nitrogen to produce ammonia. All right. So we have 3 moles of hydrogen, 1 moles of nitrogen to produce 2 moles of ammonia. So we have 3 plus 1 is 4. All right, 4 here and 2 moles here. Okay, so if you put more pressure on them, you know what's going to happen? The one that is 4 is going to become, because of the Le Chatelier's principle, is trying to shift to the other side. So what will happen is we're going to create more ammonia. All right, and you might be asked, what's the best pressure for making ammonia in a mass scale in an industrial way? So the best would be a 200 atmospheric of pressure would be very good. All right. The second thing about the Haber process is this: you need to have temperature controlled environment. So as the Le Chatelier's principle stated, that the temperature affects the equilibrium itself and the constant K itself. So how are you going to control pressure? Because this Haber process, this reaction is an exothermic reaction. So if the heat is this side, what you need to do is to lower the heat. Alright, but you don't want to lower the heat too much, or there will be no kinetic energy just colliding with each other. So not too much, not too low, so you need the right amount. And the right amount is between 400 degrees and to 450 degrees. That's the perfect for making ammonia. Alright, well, the third thing is good that for making ammonia is using a catalyst. And one of the best catalysts you can use for making ammonia is iron. Alright, so when you put the iron in the equilibrium, in the reaction and in the reaction itself, you're gonna lower the activation energy level, and then you're gonna speed up the process of producing ammonia. Alright, so let's go to the question side. Let's just produce a couple of questions based on what we have learned so far. Alright, so the question is this: is the Haber process is exothermic or endothermic? And if it is, then which temperature would be suitable? Alright, so if a question like that comes up to you, so first of all, is exothermic or endothermic? So which one is it? It's exothermic reaction. The second thing is that which temperature will be good? The temperature that is good would be 4 to 450. The second question is this: which catalyst is good for Haber process? As I earlier said, iron Fe will make a very good catalyst in this reaction. And that will be all my presentation. Thank you for listening. You have a great day.